Hi, my name is David, and this is the last video of the 2024 Holiday Hack Challenge video series. We finally got here. After the decryption of the naughty nice list, we still need to deactivate the publication of um, the information that was included in the list. And for this, we are going to rely on some of the artifacts that we extracted from the previous challenge and also a hint from Santa Vision. I mentioned this in the last video, the decryption. Well, for me, it's last because I'm recording these, but for you, this might be the only video that you're looking at. And this challenge will also include some exotic technologies. So that part was a bit weird, but I understand why they chose a database technology that is, again, not very common out there. It's kind of exotic. This allowed the creators to force you to, well, kind of reinvent the wheel and script an injection. The scripting part is not mandatory. You can do in theory manually this or using something like Burp Intruder. I think you're probably better off writing a script for the whole attack. Took me about 2 days to put everything together and have I wouldn't say polished code, but a code that is decent enough so I can present it here. And I'm going to include that one as paste bin paste under the video. In the description part, you will find a URL where you can get the script. I'll go through briefly what the script does, but the main part of this video is going to be explaining the thought process of the queries that I crafted and included in the script. And then as we execute the script, I will very quickly explain what the script does at the different stages. It's going to be one of those longer videos. You saw the previous two. It's not going to be 2 hours, 2.5 hours like the Alp stack was, but I estimate approximately an hour for this video. And just like the previous one, this does not have a silver and a gold version, just the gold version. So once you solve it, you get a gold trophy. All right, let's get started. We still have the timer running here. The clock is still ticking and we need to do a deactivation. If we go here under the objectives, you can see that aside from the game telling us that we need to deactivate it, we're not getting any additional leads. You need to work with what you already know from the previous challenges. I think that's the reason why this became the last challenge, because it is building on top of the previous ones. The two challenges that we need to rely on are the decrypt challenge, because we need the artifact for the ransom URL. So here, actually just part of it. The important part really is the debug equals true, and also the UUID, which you can kind of figure out from the URL itself, so you don't really need the debug feature. But in order to get some additional information for this challenge, we do want to have the debug true. Now, jumping back here, the Santa Vision challenge had two important hints. The Let's Encrypt cert related one was a hint for the decryption challenge, but there's also one here that shows us an API endpoint, which has the word deactivate in there. That's a big telltale sign that this is related to the deactivation challenge. And there is also a header name mentioned here. We're going to use this header name, and from the URL that you extracted from the artifacts of the the decryption challenge, then you will be able to substitute here the UID value and come to the conclusion that this must be the location for the deactivation function. Of course, we can also include the debug option here. So just like we're doing it here, we can add that the debug equals true. There are no additional variables here. for this request. So I have to do the question mark symbol here. We had the digest variable here in the URL. We had to add the and symbol and debug equals true. We're going to go through the different stages with or without debugging, and then see the differences. Yeah, I don't want to save this one here. And I think I completely forgot to copy my script here, so let me just do that one. So we're going to use a script later on to execute the process of deactivation. Well, not really deactivation, something else that is related to deactivation, but I'll tell you about that more when we get there. So let's take this URL, and I'm going to use the browser of Burp Suite. Get rid of this part here, and make a request first without the debug equals true. So this request goes to the backend, and we just get an invalid request. Let me just go here and grab this request in Burp, and I'm going to drop this one to repeater. So inside repeater, again, if I'm just sending it like this, we get invalid request. And we're going to spend some time in the repeater part. So I can also add debug equals true at the end. Debug equals true. And we can see that in the response, let me just close here the let's do it this way. I just wanted to close the inspector panel here. So we can see that now we have the debug parameter showing up. And the reason why we want to do that is based on what we know, there also should be an API key passed on. I'm just going to use the value 1 for the API key header first. So we're going to send it, and it says invalid API key. Now, this is important because without the debug part here, you can see that we just get the information invalid request. Whether we have the API key listed here or not, we're always going to get the same message. But if we have debug equals true, then we know that the API key here is invalid. So this gives us a bit more insight on what's going on. So what if I do like this weird sideways single tick character and I send it? Then we're going to see the request is blocked. So that is yet another important information. There is some sort of validation here on the input, and we can see that certain values are going to be blocked. What if I just do a normal single quote here? This is where things get a lot more interesting, because we have now this error message here. This debug function gave us this error message. Now, if you take this error message and format it a little, here's what you're going to see. So you have here the error message for doc in config, filter doc key name omitted, user supplied API key in quotes, other query lines omitted, and then return doc. Now, this is not SQL for sure. It is some sort of error message coming from a backend, but when you look at it, at least personally, when I looked at it, I was totally lost. I had no clue what this was. So probably the easiest way to identify it, you can try to search for these messages, or take the entire error message verbatim as is and just give it to ChatGPT, for example. And I already did that. So I was asking ChatGPT, hey, based on the error message, what kind of database system this might be, because in the hints they were talking about injection. So I kind of suspected that there is some sort of SQL injection or no SQL injection in place. And turns out that is the case with the backend is seemingly being something called OrangoDB. Never heard about that before. I checked it. It has a market share of 0.35%. across NoSQL database backend. So probably overall market share for backend databases is even lower than that. Probably like, I don't know, probably below 0.1%. It uses AQL, the Arango DB query language. Cool. So that is the most likely candidate. Now, some questions were coming into my head, and I was wondering if this Arango DB and AQL can be susceptible to any sort of injection attacks, because in the hints they were talking about injecting things. So you can find this on Stack Overflow, showing you examples of potential string concatenation leading to injection attacks. There were also other discussions here about AQL attacks, saying that, yeah, it is potentially going to be susceptible to injection attacks. And I found a write-up here for a CTF that was using Arango DB and injection there. So you can see some details here. Well, the fonts are probably too small, so let me just jump in here and zoom in. So you can see here certain values mentioned. Now, this one, I was very, very excited to see this one. The problem is that most of the keywords mentioned here in the write-up are going to be blocked. So no luck for us. And probably the thing that you want to also consult is, I'm going to close all these. So injection attacks definitely can be a thing. And also in the documentation of Arango DB, which we'll use extensively throughout the solution, because I don't know AQL at all. So we are going to have the documentation here. We're also mentioning the importance of using bind parameters in AQL instead of doing concatenation because of injection. Yeah, because it prevents malicious injection of keywords and blah, blah, blah. So injection could be dangerous because blah, 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 blah. So the documentation does mention the issue of injection attacks. I also just forgot to zoom in here. So we're going to rely on the documentation because of the syntax and some of the keywords. This was totally alien to me, so I had to like work out ways how to mess around with the database. So first order of business, let's try a couple of payloads and figure out what we can do with this. So a few keywords that you can find in the documentation under, I think it's under syntax, where you can find, yeah, the various keywords. So I wanted to try a couple of keywords, for example, for or similar kind of keywords, and we already saw that certain characters are blocked, and the bad news is certain keywords are also blocked. So FO is not going to be blocked, but for is blocked. Now, because we're potentially going to deal with the blind injection, because as you can see, the error message does not change. So no matter what I send here, if it's incorrect, it just gives me back the same error message. And because of that, we might have a hard time identifying what works and what doesn't. So here we might have a potential for some sort of blind attacks by doing sleep timers, if that's actually a possibility in Arango query language. We still need to figure that one out. But for example, the keyword for is blocked. I think let was also blocked. Yeah, or return is also going to be blocked. So a couple of keywords that are mentioned in that CTF time write-up are going to be blocked, which is fantastic. But for example, the keyword like is not blocked. which again kind of leads toward my idea of a blind attack. Now, I went to the documentation, took this list and tried all these, plus there's some additional ones mentioned here. And here's what I came up with as a conclusion. So things that are blocked. So these are all blocked. And we're not going to have any luck with these. So I tried a couple of things. Now, some problematic parts for later. The double slash is also blocked. Actually, I think even just a single slash is probably going to be blocked, but let's see. Yeah, so slashes are going to be blocked. Double slash also blocked. So, well, because the single slash is blocked, so it is going to be kind of annoying. However, everything else here aside is allowed. So we have a bunch of the keywords that are allowed, including things like, where is it? Like, yeah. So like will be interesting, and a few other operators that are not listed here are also going to be allowed. So these are just some of the keywords, and then we'll check some of the operations like sleep, and here the various characters for the like comparison operators. So these are all going to be allowed, and functions is actually what I wanted to check. So we will see that we can concatenate, we can use the like function, which is super important, and the different operators. But some of the keywords and characters and operators will be blocked. And we have to work our way around this. Probably the biggest problem is escaping, as we'll see it, because at least for me, the queries that I came up with will use like, and with like, the characters underscore and percentage might actually occur in some of the values that we need to figure out. So that will be problematic. And I had to come up with kind of like clumsy way of overcoming this difficulty. Not sure if my solution is 100% correct here, but I got the key at the end, so I guess it's good enough. Okay, so we know that certain things are blocked. Can I craft something that passes a validation test, or can I craft something that shows me maybe a timing attack possibility? So here, if we take the this part here into account, and where our payload is inserted, so this value here must be in a form that kind of works in this position between the quotes. So I probably have to have an opening and a closing quote. So one thing that I came up with is something like this: one single quote, or A equals B, and I'm not closing the single quote here, because if we're pasting, let me just take this part here, I guess. If I'm pasting this one into this position, here's how the payload will look like. That should pass at least the syntax checking. And then this should be returning false, most probably. So whatever this p name here is, the value is probably not going to be a 1, and this should validate as false. So let's take this payload and check out if it actually works. And instead of the syntax error, I'm getting an invalid key now, meaning that, basically this is the equivalent of just sending the 1. So I can add additional details here, and this ends up with an invalid key, just to prove that if I mess up the syntax with another single quote here, just setting a single quote, I'm getting back this error message once again. All right, so this is something that works. Now, the bigger issue is how can I tell if my expressions will validate correctly or incorrectly? Um, and if you look under functions, there is a sleep function, which can allow us to perform time-based attacks. So let's check another payload idea. So what if I place a sleep here, and then depending on whether my expression validates true or false, this might be executed or might not be executed. So here, my sleep function, in case this is true, should not execute because this whole thing validates true, so there's no need to do the validation. This is also kind of exploiting how Orango DB will validate this. So my payload will go into this position. Synthetically, it should be correct. And I should see a sleep of 3 seconds, which we're actually not going to see, but there's a reason for that. And I think that's probably from the creators of the challenge. So this should, no, sorry, this expression, because this validates as true, should return, you probably cannot see it because of my face here, but let me just position burp in a way where I can show you. So in case of burp, you want to, I'm going to try to zoom in now. Ooh. I'm not sure if this is actually zooming in on the recording, so I should probably try something different. Anyways, you have to kind of trust me that here the return time is 142 milliseconds. So here burp gives me that. If I have something that validates false here, so I put a B here, then this function must be also validated. So we should see a sleep of 3 seconds. And actually, you can see that it takes a much longer time, but it takes 2 seconds plus 100, let's round it up to 40 milliseconds. So that 140 milliseconds is probably the max delay that we'll have approximately. So there's a normal delay response time between the backend and, well, my location here where I'm based at. And the sleep just adds 2 seconds of delay. I can go up to 10 seconds even. It's always going to return within 2 seconds delay. So I think there is code on the backend to ensure that you're not going to waste too much resources. So if you have a sleep function, I think they're going to swap the value there or something like that to make sure that you only wait 2 seconds. I left all my sleep to 3 seconds just to be sure. But in my code, when I validate for the delay in the response time, I'm looking for 2 seconds delays because that's a maximum delay that you're gonna get. So it's basically safe to just have sleep 2. If you go with sleep 1, that does return in 1 second and 140, 50-ish milliseconds. That is not always reliable. So sometimes, especially under higher workload, the backend might respond a bit slower. So my recommendation is go with sleep 3. And when we craft our queries, we're going to be careful and try to make sure that our sleep will only kick in for cases when we find the right character, to find the right values, and for all the values that are not the correct ones, we try to return with the normal speed of 140 milliseconds. That is basically the optimization that you can do with your queries. But this proves that the sleep function does work. It is accepted. And the next idea then is to craft a query that allows us to figure out in this query the name of the key. So doc is like a table here, but this is a NoSQL database, and it's kind of similar to a select from kind of query. The filter is like a where clause. So we see very similar elements to a SQL query, but we have to figure out the name of the, they call it keys because this is a key value pair database, but you can think of it as the equivalent of the column name in a database. So these are called key names or attributes. Let's look at the documentation for some details. So the attribute name is something that we need to figure out. And we need two things for this. There is a function called attributes. Things are kind of slow now for the documentation. I really hope that I will be able to show this to you. Okay, finally. I'm going to load in the other parts of the documentation as well, just to be sure, because I'm kind of worried that we might not have the documentation around. So attributes is a function that returns the list of key names. And you can see here the example. So if you ask for the attributes, then you will have foo underscore key and underscore custom returned here. There are some built-in ones like underscore key underscore ID, and in the attribute names, you can have uppercase, lowercase. There's also the underscore ref. So there's some built-in attribute names, key names that we need to be aware of. And the underscore character is one that can occur, which is problematic because I want to use like for my blind injection. I cannot escape the characters. So I need to work my way around the underscore character, which can and will occur in attribute names. So if I take the attributes and just call it like this, it will take all the attributes in that document and return it as an array. This is not great for me because I can't really work with an array. At least I couldn't really figure out proper ways. And we also have some restrictions on the keywords that you can use. So my idea was to use a concatenation. So this one takes a list of values. It can be an array, and we can concatenate these with a separator character, or we can just omit the separator character and just concatenate the string of the values that we provide. So my idea was taking the attributes function and then use the concatenation function to concatenate the strings, and then this is not loading. The only thing that I need now, there we go, and then use the like function to see what characters are actually included in the attribute names. And a very similar approach I can take for getting the actual value of a field. So here we already established that the sleep function should work, and now I need to craft a special query that will allow me to figure out the characters. And this will be a 3-stage approach. So still need to figure out the name of the attributes. I need to kind of optimize this. So I could go and just get the attribute names, so the names of the keys, concatenate them together and run a like against it, trying to go letter by letter. I try to be a bit smarter about this, and I'm going to first figure out what characters are included, because I just need to go through one time with the alphabet, and then I will have a much more restricted, a much smaller alphabet. And I also want to figure out the length, so I know that when I am going character by character, how long do I need to go. And finally, I will figure out the characters based on the reduced character set. If this sounds very complex and weird, I am going to go through the process. And once I have the key name, then I can go for the value. So I need to change my query a bit and they're the same steps. So figure out what characters are included in the value. We will see that it's a restricted character set, basically just hex characters. And then I need to figure out the length of the value and then the actual value for what is going to be the X API key value for us. So that is our plan. Let's try to craft our requests. So the first request that we're going to look at will help us determine the character set of the key name, the attributes. So I'm using the attributes on the doc document. So this will return all the key names from the doc that we're looking at. So here for doc in config. So we take the keys from the doc with the attributes. This creates an array, and then we're passing it on to the concat separator. We're going to separate them by the I'm actually, I think in the code, I'm not concatenating them for this query. So it's just like this. Yeah, I had an error in my notes. The reason why I'm not including my separator character here to determine the character set is because I don't want the separator to be one of the characters. I'm going to add that back one later, but I want to make sure that my separator character is not part of the original character set. So when I am figuring out the character set, I want to make sure that I'm only going to list out characters here that are included in the attribute names. And then when I'm actually trying to enumerate character by character the attribute names, then I'm adding back the separator character, also to calculate the full length. All right, so we have here an expression where I have not like for this concatenation of the attribute names. And the like function is going to check letter by letter. Here I have the letter A being checked. You can see here also the attribute of this function. This can be true or false for case sensitive or insensitive search. Now, because the attribute names can be upper and lowercase, I'm going to do a case sensitive like, but when I'm matching the characters, I'm just going to do case insensitive. It shouldn't matter, by the way, because once I figure out the right character set, that means that that is the final character set. So I let you decide whether you want to do the here for later stages, the case sensitive or insensitive match. Here it matters because I'm figuring out what kind of characters are actually included. So I want to do a case sensitive like here. And you can see that I am saying not like. So the idea here is whenever I have a character that is not part of the character set of the attribute names, so the names of the keys, I want to fail faster. I can leave this one without the negation, but that will result in a 2-second delay every time I have a character that is not part of my character set. That is the more likely event, however. So to speed up the process, I'm going to negate this like statement here to make sure that whenever the character is not part of the character set, this whole thing validates as true, and the sleep is never executed. When I do have a character that is valid, then this will be true, this will be false, so the whole expression is false, and then sleep is executed. That's the less likely event, so I want as little delay as possible. And then here, just for the syntax, I have at the beginning, at the end, my one and single quote, and then in single quotes, A equals single quote B without the closing single quote. So this ensures that my syntax is correct. So that's the idea. Again, getting the attributes in an array, concatenating them together, seeing if the character that I'm currently enumerating is in the character, is in the concatenated attribute names, case sensitive search, And then I'm negating the whole thing to fail fast on the cases where the character is not part of the character set. Okay, so that's the idea. Let's see it in practice. So sending in this request and we see a delay. That means that the letter A is part of the character set of the key names. And I can't remember exactly. I think the character B shouldn't be. So this returns much faster. Okay, so that is the blind injection idea. B returns faster because this whole thing validates as true. So this one until the or before the not validates as false, not changes it to true. So the rest of the expression is not going to be validated by the backend, meaning that it will return faster. Hopefully that's easy to understand with the explanation. If not, then just ask in the comments and I will try to explain it in a different way. So I want to fail fast for cases where the characters are not in the values that I'm trying to enumerate. And for cases where they are, I'm willing to take that extra like 2 seconds of delay. All right, so this will allow me to map out what character set do I need to apply. Once I have that, I can move on and try to figure out the characters. But before doing that, I need to figure out what is the exact length of the concatenated characters. Let me just go back to the documentation pieces. So luckily there is a length function, and the length function will return the length of the string that I'm feeding into it. So the idea is the following, and I have a modified query for this one. So we're just going to change the query a little bit, and instead of the like, I'm just going to use a length, and I'm going to validate kind of enumerating from 1 the length of the character set. Again, I'm going to negate the whole thing. So for cases where I don't have the right value, this will be a false. This changes the whole expression to true, and then sleep is not executed. So I'm going to try here the length for the concatenated attribute names with the separator symbol. This will allow me to have the exact names, and I don't have to like make any guesses. And let's see if the length of the concatenated values is 31, which is not. So this expression returns much faster. And then what if I type 32? I have the 2-second delay here. 33 returns fast. So that means 32 is the right value. Now I'm going to show you how the script figures this one out. It makes a series of requests, of course. So it starts from 1, 2, 3, 4 until it finds a delay. And that means that I had the right value here. And I'm going to use the same approach to figure out the length of the value that we need to get out from the database. All right, so the length we are able to figure out. We do have the character set. So next order of business is to figure out the actual values. And this query is only different in one single character. So to get the character set, I had percentage, the character, and then percentage. Here, what I'm going to do is I'm going to remove the percentage from the beginning of my payload. And then I'm going character by character. Does the concatenated attribute name list start with the letter A? No, it does not. Does it start with the letter B, C, or the letter D? And it turns out it does start with the letter D because I have that 2-second delay that you could see with the response time. Okay, and then I can move on and add another character. So once my script will see the delay here, it moves on to the next character and it starts DA, no, DB, no, DC, no, DD, no, DE. Now we have another delay. So we'll keep adding character by character until I see a delay, the possible combinations, and this will tell me if I managed to find the right value, and I can move on until I reach the end of the length that I enumerated previously. So it's going to be a 3-step process. Determining the character set. So at this last stage, the first stage, when I'm going to try to enumerate character by character the value, I am not wasting time on characters that are not present in the character set. So this speeds up the script a tiny little bit. This is still a pretty significant gain, by the way, but I'm changing the base, not the exponential here for the total number of combinations. Still, we're going to significantly reduce the base of uppercase, lowercase, number, special character set to only a small set of characters. So this will be a big gain for us. Then I will determine the length, and then once I know the length and I know the character set, I'll try character by character, figure out what is the value until I reach the end of my length. And that means I'm done with the enumeration. And this is just for the attributes. So once I have the attribute, and here I'm going to do a spoiler. So if you don't want to know the name of the attributes, just skip forward to the script part. But the point where I have, I'm just looking at my notes here. Yeah, the point where I have the list of keys will tell me that the key that holds the API key value is called deactivate underscore API underscore key. So we have to enumerate this, and we will see some additional key names, the default ones like underscore rev, underscore ID, and I think underscore key for the primary key. So once I have that, I can go and try to get the actual value of the deactivate API key. And the idea is going to be exactly the same. So I want to first determine the character set. Does the API key have the letter A? And you can see from the delay, it does. Does it have the letter X? No, it doesn't. So we're going to enumerate, excuse me, we're going to enumerate the list of characters. Then I want to determine the length of the value. So that's going to be a different query, similarly to the attribute name one. We're going to use the length function here. We're going to ask, is the length of the API key value is 35? No, it is not 35. Is it 36? Yes, it seems like it's 36. From the length, you can probably figure out that this is probably just another UUID value, and you would be right. You can see that if I go until 37, then it returns again fast. So this is again a valid way to determine the length of the value of the API key. And then I need the actual value. So step 3 in the process, once again, is using a query that is very similar to the, oops, sorry, not that one. So very similar to the step 1 query, but instead of having the percentage here, I'm just going to do letter by letter the enumeration. Is the first character A? Yes. Are you sure it's not B? Yes, I am. So with the letter A, I have a delay. Okay. Then I can go on the next character. Is it AA? No, it's not. Is it AB? Apparently it is. So we have the first 2 characters of the key. But obviously I don't want to go manually through the process of finding the character set, finding the length, and then enumerating the values. So I wrote a script, and it's an ugly, ugly little script. It is not a nice one. So if you're expecting a nice polished script, then I have to disappoint you. Now you also have to keep in mind that there is a rate limitation in place. I won't be able to show this, but I do have a saved response. So if you try to send more than one response at a time to the backend, you're going to be rewarded with a message like this. Let's put here a separation character so you can see it. So you're going to get this message here saying 400 bad requests, 1 API request per bot at a time. So my script is single-threaded, and it has to be single-threaded because nothing else will work. So the enumeration is kind of slow because of this, but that's really the only way to do the enumeration. Okay, so I have the script here. What I'm going to do is I'm going to have the terminal running here. We're going to have Python free search API key. Wow, what's happening? There we go. So I'm going to execute this script, and we are going to also take a look at the script in the meantime. What I need to do, however, is I have to change the UUID value here to the UUID that I have from the previous challenge, or from here. So you can paste it from whatever location you have the UID located, and you just have to adjust that part of the script here. That's the only input that the script needs. And you have here the expected output. I also left here some debugging options. If you want to skip certain stages, certain steps, you can just use these and comment out the rest. And you can see that we're going to go through those 6 stages, and at the end, this is going to be the API key, hopefully, that we'll have. Now, sometimes the script fails because of delays and finds characters that are actually not part of the character set, or it stays in a loop because it does not find the right character and makes a mistake. We'll see. Hopefully, everything will go well. The way I tested it with the 2-second delay option is relatively stable, but we never know. Eventually, you will still reach this API key. At least the 2 tries that I did on the original solve and then the testing before the video recording shows me that that is the API key that should be returned by the script eventually. We also have here the expected outputs for the length, so you can see that these are going to be the list of characters there. Actually, the underscore character is not part of it. I will explain as we run the script why I have that one. And I also was kind of lazy here. So we have a function that sends the payload, and then for the actual payload part, I have a mode operation, mode attribute rather, that determines what is the query that we need to send, and I have the f strings here. I'm pretty sure you should be able to pass on f strings as a parameter and then construct an f string, for example, with concatenation. I felt that kind of makes the code uglier, and instead I decided just to have this way of differentiating if we're in the attribute stage or in the key enumeration stage, because the 2 queries are different. So we have one function that gets the character set. Then there's also this function that clears out the character set. Again, more on that in a bit later. Then getting the length and the 2 queries here that I showed you earlier, and getting the actual values and the 2 queries that I showed you earlier. So we have a function for all the stages, and have one helper function that clears out the character set. So why do I have this clear function here? When I run a like, and I try to figure out the character set, if I place the percentage character here in the injection point of my payload, because of like, this will evaluate into a kind of bytecode, and it will return a true. Same goes for the underscore, because that's also a bytecode, but just for a single character. So these characters will be always found by the get character set function. And the percentage, I don't expect to show up in the name of the attribute or in the value. However, the underscore does occur in the built-in key names. So I need to kind of fix that. And if I see the underscore character, I'm going to remove it from the list of characters, because I don't know which position it might occur in my found characters list. So I'm going to remove it from the list, and then I'm going to append it to the very end. I have to do this because I'm not able to escape this character, because the slash is a blocked character. So I cannot include that in my payload. So instead, what I'm doing is I'm moving the underscore character to the very end of my character list because I'm starting always from the beginning. And as I enumerate the characters one by one, if none of those match, but the underscore does match, because I already enumerated all the possible characters, when I'm enumerating the value one by one, if I have a match on the underscore, that is a case that can only occur when I have the underscore character in that position. Hopefully that is something that you were able to understand with the explanation. So I use this little trick to make sure that when I have a match on the underscore character, the only case when it can occur is when I really have underscore in the value. And it's not a white card because of the like. Not here, but when I'm enumerating here or here. Hopefully that makes sense. Again, if it doesn't, just let me know in the comments and I'll try to explain it again. So, all right, we are ready to go and ready to launch the script. Now that I actually saved it, so we have the right UID value. Okay, let's give it a try. It might fail spectacularly. So you can see the testing character set, and we are sending the characters one by one. And we reach the character A, then the script says, oh, I found a character here. I found the letter C, the letter D, the letter E, F, G, H, I is also in there. So the script will let me know which characters I found. Then, while it's enumerating, let's move on. So I'm searching for the characters in the printable character set. So in the Python string library, printable is going to be all the uppercase, all the lowercase, all the numbers, and all the special characters, and some of the white card characters, well, not white card, white space rather characters. And these are all valid characters according to the documentation. But you see that, for example, the uppercase characters were pretty much just flying through them. So we have all the lowercase characters already enumerated. This list looks pretty good to me. And you can see here that the percentage symbol was also validated as a found character because of the like. So we're going to fix that one with my clear character set card, which will purge out the percentage character and place the underscore at the very end. And then, we're going to ask the user, or you can just hard code this, to provide a separator character. So once we enumerated all the possible characters, here the script is asking me provide a separator character. Please don't use percentage or underscore, because those are characters that we're going to purge. So I'm going to provide the pipe symbol here. You can use a different character. For me, it just comes naturally that this can be a good separator. Then we're removing the special characters and adding the separator. And then we are going to make sure that the underscore is at the very end. Next, we're just enumerating the length. Again, this is done by the length function here. And we're using this part here because we're in the attribute section. And we figured out that the concatenated attribute names with the pipe symbol are 32 characters. And now we're just going one by one and enumerate the value of the concatenated key names. So we can see that the forming of the strings with the act, and then deacti, should be a V. There we go. So letter by letter, we are enumerating, as I explained before, and this is using the get value with the node attribute. So we're using this as a payload, and we are inserting character by character here, the letters from the character set. So this function has an input of length, the character set. So this is what we found with the get character set function, the mode, and the attribute name part is something that we are going to provide here as a default value. The attribute name is something that we are going to figure out from the attribute list. And I do have here, I believe, yeah, a little logic to use the there's a bug in the code. I can see it here. So here we're doing a split on the pipe symbol, but it should be the separator character here that we provided. It's not really a bug, but if you use a different character set, this will break. I'll fix that one in the code and just use the separator character here. And I also need to make sure that here the separator character is hard-coded. So I'll fix that one. Try to remember to fix that. If it's not fixed in the paste bin piece, then just let me know. And here the script will hang and it will wait for me to provide me the attribute name that I want to enumerate. So here the logic is that I'm not sure what is the name of the key, and I'm looking for either the key string or the API string appearing in the enumerated list of strings. We can see that the key name is actually deactivate underscore API underscore key. And then you can see here the issue with the underscore character. So we need to go through character by character until we reach the underscore character, which will be always matching the character at that position. But because we placed it in the last position, the only way this can be an underscore match is that the actual character is being the underscore. I can see that we're enumerated here those default key names, the underscore rev, underscore key, and the last one I think is underscore ID. Let's see. Yeah, there's an I, and the last character is a D. And we are done. So that is the maximum length that we enumerated. And then we need to provide the name of the attribute that we want to then enumerate for the value. So at this stage, we are going to move on for the key value enumeration. And we need to figure out the character set. And because it's a UUID for the value, I'm just kind of worried about the free not being found, but this can be actually a case. So let me just check. Okay, I don't see free in this value, so the script is still good. We're still good. So free is not there. 8 was not there. Is that correct? There's no 8 or free, but we have 2, 1, 4. Should be somewhere. There is a 4. There should be also a 5 somewhere. Or there was no 5. Yeah, that was a 5. So somewhere there should be a 5. Oh, there it is. There's a 5. Okay, so I'm trusting my script. I'll trust my script. So it found almost all the numbers, but not all the numbers are actually present in the value. So it correctly skipped 3 and 8. And then the letters from A to F. And all the other characters here are just going to be ignored. And here at this stage, we're not asking for the separator character because we're not doing concatenation here. We're just going to do a like. So the script moves on to figure out the length of the API key, which should be 36 as we saw it, as I explained the logic. So you can see the character set here. And again, this speeds things up a little bit. If you would like to use sleep 1, it can be done, but it's going to be, again, a little bit flaky. So I would be careful with sleep 1, but it should work. It might be a bit more error prone. This version of the script, by doing sleep 3, or you can also just change it to sleep 2, it will have the same result, is a slightly slower one. The gain of using sleep 1 instead of sleep 2 is, if I remember correctly, it's less than 3 minutes. So we're not gaining much with that. I think the important part is really to get the right character set and then make sure that your queries are going to validate true for all the characters that are not matching, because there are many more cases compared to the cases where you are finding the right character. Okay, so we can see that we have A, B, E, 7, A, 6, A, D so far. And that is correct. So the script is just working fine. Of course, this will take some time. Now, the last thing that we will have to do once we have the actual key is to make a request to the deactivate URL. So this one here, Frostbit admin deactivate, and we need to provide the right XAPI key value, which is going to be this one here. So my final query should have this value, which means here, because I was just messing around with the XAPI key, I would have to send in this request. We need to wait until we enumerate all the characters just to see if my script is actually able to do that. We need to wait a few more minutes, and that will be the end of this. And we should also see the, I'm going to close these windows. We should also see the objective with the gold trophy. This is validated automatically, so once you do the deactivation, we'll see a message that contains 200 response and then returns values like some grid, some hash value, UUID, and so on. We will see it here in the response part, and that will be the end of this challenge. So pretty cool challenge overall. I think this was a lot more enjoyable compared to the Decrypt challenge, a lot less brain twisters. You just have to logically put together your queries based on the documentation. It takes quite some time to get through the documentation and figure out the various pieces, but these functions can be also found in SQL. So if you know the concept of time-based blind SQL injection attacks, this is actually one that you can pretty easily figure out. And I'm pretty sure there are other ways using the other functions. These were just the ones that came into my mind initially because, well, they're very similar to how SQL works. So like is like here as well. A sleep, a length function is the same. Attribute function, concatenation kind of works similarly to the SQL equivalents. I think we only need a few more characters now. There's the last two characters. So F is also found. Then there's a 9, and at the very end there's a 1. All right, perfect. So there we go. We have the final key here. And we can take this one. I'm going to actually copy this and paste it in here just to show you that that is the actual value. Let's show it again. This is the value that the script found, and that's the value that I'm going to submit. You can see the response code 200. Quickly going back here, and we have the challenge completed. I was fast enough to see the actual event occurring. Okay, so that concludes the challenge, but a job is not done. Job is not done. So we have now Act 3 completed, but we need to talk to Santa. So let's toilet travel and talk to Santa. Santa is going to be very, very, very happy that we managed to deal with the ransom and deactivate the publication. And now the hole is open for us. I wasn't really poking around. I don't see the chickens here. There should be somewhere the chickens. Or hens rather. They're not chickens. So the hens should be around somewhere. Didn't find them. So if you want to look for those Easter eggs, feel free to do that. We're just going to talk to Santa. And keep in mind that until you are not talking to Santa, your score is still going to be 80. So if you look at the scoreboard, I still have just 80 points. And the final conversation with Santa and the rolling credits and the achievement will give you 100% 100 score. I just want to check the scoreboard. I'm the 100th account that solved this. I already have position 61, so that means that there were so far 99 accounts, or 99. Well, yeah, 99 accounts that are not mine, but me included, solving the challenge. That is actually a surprisingly low number. I was expecting that since this is the last day, so I'm recording this on the 3rd of January, I expected to see a much larger number here. Because 2 of them is mine, there's at least 99 people, so let's round up to around 100 people solving this, because this is still 5 in the afternoon here, and I'm based in Europe, so people in the US might just finalize their submission, and we might see additional people scoring here. But I am in the 100 position now, which was not intended, but it looks pretty cool, and that is really giving you an idea how many people play these holiday hack challenges and how many of them are actually competing for the prizes. And it kind of surprises me. I'm obviously not competing for the prizes because the grand prize is a SANS class, and being an instructor, right? I don't really want to take away the opportunity from people taking SANS classes. But there are other prizes as well. There's also the prize of getting wars, randomly drawn prizes, and obviously you will compete even if you're not solving all the challenges for the random draw. But for the final grand prizes, you really need to solve, I think, all the challenges, and you're only competing with approximately 100 people, at least this year. Now, this was, I think, one new set of amazing challenges for this year. Compared to previous years, I think the pace, and largely thanks to the way they released the challenges, which was much more relaxed. I was very happy to work on this phased approach, and you could do the challenges as they're released or take your time. For the first 2 releases, for the prologue and Act 1, I jumped on the challenges immediately as they were released and tried to solve them as fast as possible. For Act 2, I was busy, but I could later solve them and release the videos here on the playlist. And for the last set of challenges, I think it's really cool that there is still a part that is going to be the final big release of the challenges, and some way to evaluate who really worked and towards the very end and solved all the challenges. So pretty cool list of challenges this year as well. If I want to be brutally honest, enjoyed the previous year a lot more because the larger set of challenges, and also I really enjoyed the fishing challenge. That was a bonus challenge last year, but that was by far the coolest one in my opinion, because you had to automate a game, and that was pretty interesting to see what other people did to do the automation. Some people used Power Automate, some people used JavaScript to automate the process. I used something different, an automation tool that I used in the past. If you're interested, check out the video. And I really enjoyed the fact that you had to like explore the different islands, ship around. So it was really an extra game inside the game. That was really, really cool. And the fact that it was a bonus challenge involving with the fishing part was also pretty cool. The challenges this year, I think they were much better balanced though. Some of the challenges last year were extremely hard. Here, I almost completely agree with the difficulty scoring. So it really feels right that like the KC7, you had to work a lot, but it was still, something that you just had to work through. Center Vision was already like pushing it. And these last two challenges for Decrypt and Deactivate, those were really brain twisters. So here, Elf Stack is probably the only one that I would probably rate a 4, but the rest of the challenges were spot on. Like mobile analysis was, pretty much a breeze, I think. So 2 snowflake difficulty level is pretty accurate. Pathfinder 9000, yeah. So even the easy one, I think, was kind of tough, but not impossible. But the hard one, I think I spent a lot of time with this, like hours. We're talking about hours here. Not as much as the Decrypt one, of course, because that one was, for me, it was measured in days, not in like net value, but that was quite a lot. Okay, so the end credits. I think the folks at CounterHack also did a wonderful job, and everyone participating, because I think for the challenge creation, there's more than just the CounterHack folks, but overall, I think it was again an amazing journey. And I'm I have to say I'm also relieved that I'm done with this. Okay, now I just need to finalize this video and upload it, and then I'm not going to again compete, but I will submit my solutions because I want to let the CounterHack people know that I really appreciate what they do every single year here. Also, I appreciate your attention. I think this phased released approach generated a lot more interest in the walkthrough videos, and I see this one in like number of hours viewed. You guys watched a lot of the videos, me talking through them, so you're probably fed up with my voice. I will finish this video, I promise, but I do want to ask you, if you watched this part and you are not subscribed yet, but you found value in the videos, then please subscribe. I have some plans for the year 2025 for the channel. After the Holiday Hack Challenge videos are released, few weeks from now, we will have season 2 of the podcast series, the Road to InfoSec podcast series. I interviewed a bunch of other folks, not just from SANS, but I have people from other companies. Well, the instructors are not really employed by SANS, but they work with SANS. But people who are not part of SANS were also interviewed in this next season, and I hope you will enjoy that one too. I also have plans for other video series, and of course, we'll return next year to solve the Holiday Hack Challenge for 2025. Thank you for your attention. If you haven't checked the previous year's videos, then you might want to check those playlists, and the last 2 or 3 years of Holiday Hack Challenges are available still online, so you can practice for next year. Thank you for your attention, and see you in the next set of videos or next time. Bye.